Hi everybody. This video is about solving quadratic equations by completing the square. Now this is one of the more difficult techniques that you'll see in beginning algebra, so it does take quite a bit of practice. I have the steps on the right side of the screen. So the first step says move the variables to the left, the constants to the right, and leave a blank space. This is really just a preliminary step getting ready for the main part of completing the square. So I'm going to leave the n squared where it is. N squared. I'm going to move this negative n to the left hand side. I already have a negative 15n. I'm adding a plus 1n, so that's minus 14n. And then I'm going to add a positive 44 to both sides, so that's 44 plus 3 is 47. Now, you'll notice I left a blank space here. You'll see what that's used for in just a moment. Step 2, make the leading coefficient 1. The coefficient in front of the square term needs to be 1. It has to be 1. So if there was a number here, I would have to divide by that number, even if that involves introducing fractions into the other terms. Alright, so the next step says complete the square, and in quotes half and then square. So we're going to look at the coefficient of the linear term. I really don't care that it's negative. That's not important. So we think to ourselves, we have the number 14. Half of that is 7, and that number squared is 49. So this number 49 we add on the left-hand side. Of course, if we add that number on the left-hand side, we have to add that on the right-hand side as well. So I add 49 to both sides. Now, you might be asking, why do we want the number 49? Well, the next step says factor, and in parenthesis, perfect square. There's a factoring pattern. When you have the number 14 and 49, or in general, if you have any number as your coefficient, and then you have half of that number and then squared, that quadratic will factor into a perfect square. N times n is n squared. We have negative n's, so I know this is going to be negative, and then 7 times 7 is 49. So if you were to use the distributive property and multiply this out, you would have n squared minus 7n to combine to get you negative 14n, and then plus 49. So this factoring pattern, half and then square, will let that quadratic factor into a perfect square, and that's the key to this technique. On the right hand side, we just have a number. 40 and 40 is 80. 9 and 7 is 16, so that's 96. And now we're home free. The next step says root, so we're going to take the square root on both sides. You don't have to draw this square root symbol, but just to make it clear what we're doing here. And on the right hand side, just like when you're solving by taking roots, I need plus or minus. So on the left hand side, we just have n minus 7. And on the right hand side, I have plus or minus the square root of 96. So my preliminary video before making this one was about simplifying square roots. Now, the square root of 96, we have to simplify this square root if we can. Now 96 is not a huge number. You might have trouble factoring that one in your head. So just like I mentioned in the previous video, if necessary, make a factor tree. So let's see, 96, 4 goes into 96, 4 goes into that, 4 goes into 9 2 times with the remainder of 1, and then 4 goes into 16 4 times. So we have now 24, and 24 is 4 times 6. Now, if we would have noticed, well, 96 is a multiple of 16. That would have been faster, but again, 96 is kind of an unusual number. So, at the next step, we're going to solve. So I'm going to go ahead and add 7 to both sides. So 7 plus or minus, well, the square root of 4 is 2. The square root of this 4 is also 2, so normally I wouldn't write this in 2 steps, but just for emphasis I will. The square root of 4 is 2, the square root of 4 is 2. We can't do anything with the 6, so that stays underneath the root. And let's just clean this answer up. 2 times 2 is 4. So 7 plus or minus 4 times the square root of 6 is our answer. Now it is possible that when you're doing this, if this number was a perfect square itself, so instead of 96, let's say we got 100, well, the square root of 100 is 10. You've got 7 plus or minus 10. Do the arithmetic. 7 plus 10, 7 minus 10. Get the two different answers. Anyway, that's the basic technique. I am going to do a couple more examples. And rather than clearing the entire screen, I want to keep the steps, so give me a moment to erase all of my work here. Takes a moment to do, but I do want to leave the steps on the screen because, again, completing the square, in my opinion, is the most difficult technique that you see in a beginning algebra class. All right, so here's another example. Let's get the preliminary work done, move the variables to the left, the constants to the right, and leave a blank space. So 8k squared is going to stay where it is. I'm going to add 16k to both sides. I'm going to move the 29 to the right hand side, so 29 plus 5 is 34. Now, the next step says make the leading coefficient 1. If you forget this step, you're not going to have a good time with completing the square. That cannot be 8k squared. That has to be 1. So we have to divide everything by 8. So k squared, no problem. 16 divided by 8 is 2, no problem. And here you'll see why students typically don't like completing the square a whole lot. 34 divided by 8, well, that's a fraction. We can simplify the fraction. It's going to be 17 over 2. Sometimes you have fractions in your problems. That's life. Now, the next step says complete the square. We look at the half and then square pattern. So you're looking at the number 2. Half of 2 is 1, and then 1 squared is 1. So we need to add plus 1 to both sides. The next step says factor, and again, the factoring is actually the easiest step here. Assuming you've done the arithmetic correctly, the left-hand side will always factor into a perfect square. In this case, k times k is k squared. We know we need positive k, so this is a plus sign. And again, this half number, that's what's going to go here. 1 times 1 is 1. On the right-hand side, if you need some scratch paper to add the fractions together, please use it. But 17 over 2 plus 2 over 2 is 19 over 2. Take the square root on both sides. So we have k plus 1 is plus or minus the square root of 19 over the square root of 2. Now, in my preliminary video on dealing with roots, we saw this. We do not like square roots in the bottom of a fraction. So I have to multiply by the square root of 2 in the top and the bottom. I'm multiplying by 1, and this rationalizes the denominator. So we subtract 1 from both sides. So we have negative 1 plus or minus, well, 19 times 2. We have the square root of 38 over square root of 2 times the square root of 2 is 2. Just like I mentioned in the prior video, the number 4 does not need to cross your mind here. Now, this is a perfectly fine answer. However, what a lot of people will do, and you'll see why they do this when we cover the quadratic formula, is they'll go ahead and get a common denominator, which is 2 in this case, and that lets you write the answer in this really nice form. Negative 2 plus or minus the square root of 38, all of that is over 2. So another example of completing the square, a little bit more involved this time. I want to do one more example though, and this time I am going to clear the entire screen, pause the video and write the steps down if you need to, especially if you're learning this for the first time. So one more example. Looks simple. Let's see what happens. So the first step is our preliminary work. 5a squared stays where it is. I'm going to add 4a to both sides. I'm going to move the 3 to the other side, and I'm going to leave a blank space. Step 2, I have to make sure the leading coefficient is 1. So I need to divide by 5. A squared plus 4 over 5a equals 3 over 5. Fractions are perfectly fine here. And it's this step of arithmetic that causes the most trouble when we're completing the square. So remember, the pattern is half, then square. So we're starting with 4/5. Half of 4/5 is 2/5, and that squared is 4 over 25. So I have to add 4 over 25 to both sides. Well, the next step says factor. Again, you might think that that is going to be difficult. This is actually the easiest step. So I know, assuming I've done my arithmetic correctly, that the left side factors into a perfect square. A times a is a squared. I need positive a's. So what about this number? It already crossed our minds. This half number will be the number that goes here, because 2 over 5 times 2 over 5 is 4 over 25. Use the distributive property and verify that you do get the middle term, and you will. Now on the right hand side we have to add fractions. So the common denominator is 25. 5 times 5 is 25. 3 times 5 is 15. So 15 plus 4, we have 19 over 25. Now take the square root on both sides. So a plus 2 over 5 is plus or minus. The square root of 19 can't be simplified, but the square root of 25 is 5. Now, we're done. Just finished solving. We have negative 2/5 plus or minus the square root of 19 over 5. This is a fine answer since the denominators are already the same. Let's go ahead and combine this into a single fraction. And there you go, negative 2 plus or minus the square root of 19 over 5. Now just a caution when you're solving quadratics by completing the square. One reason that this is difficult is you'll do all of the algebra and you'll get an answer that looks like this, and this is not a very pretty number, or pretty numbers, there's two answers here. But you might not notice if you've made a mistake in the problem. A lot of times students get in the habit when they're doing algebra, if you get down to your final answer and it's a weird looking number, well, you might think, well, I've made a mistake, and then you check your work. Well, a lot of your answers are going to be weird looking when you complete the square. I highly suggest verifying your answers in a calculator. In the TI Inspire cache, you could go back to the very beginning, menu, algebra, solve, type the equation, comma A, and verify that your answer is right. Because completing the square, this is a technique that does take a lot of practice. Anyway, this is how you do it. Hope the video helped.